Hello and welcome here to the headquarters of Volvo Cars in Gothenburg, Sweden. And thanks for having us at this virtual event from the Influx Days. We would have loved to meet you in person, but we're happy as well to share our experiences with Influx here at Volvo Cars on this virtual occasion. My name is Daniel Putz. I'm the product owner of the product called the DevOps Enablement here at Volvo Cars. And with me I brought as well Maksim Puzykov. He's a senior engineer here at Volvo and basically the architect and head behind of setting in Influx setting Influx up in this enterprise environment. Maxim will later on tell a little bit about the practical examples of how we set it up and a little bit about the technical details. But I will start now by telling you a little bit about our history, or rather about the past 3 years of the change that we've done within the monitoring setup. And as well a bit about the reasons for it and why we went with Influx basically. So Maxim will explain you later on. See you soon. So let me get started and let me right away from the start tell you the 3 things that I hope you will take with you from today's presentation. The first one is the importance about transparency when working with your monitoring environment and working with the information in general, how important it is to be transparent about it. The second point I hope you will take with you from this presentation is about self-service and the importance of self-service in today's environment and today's setup where we want to have autonomous teams working, developing and operating them codes themselves. And the third piece is about the mindset and the challenge behind changing a mindset in such a big environment like we have here in Volvo and the challenges behind that. But let me start with where we basically started 3 years ago when we looked into our monitoring setup. And you can basically say it looked a little bit like this. There was a tool in place that was there for the past 1.5 decades, maybe 2 even. That was growing from an infrastructure perspective, monitoring infrastructure. And it was stable, like this Volvo Amazon. It was reliable, it was doing its job. But maybe it was a bit outdated. It wasn't really the stuff that our developers wanted or needed, and we had to do something about it. As well, we experienced a lot of problems and incidents within our IT environments. And since we are a producing company, one of our biggest problems is when the factory stands still. And we got the question of why do we have so many problems within our infrastructure? Why isn't our monitoring working properly as it should? So one of the first things we said was we want to see the information and we wanted to understand how well we're doing with the monitoring. For that, you have to understand that back in this old setup, there was a small team responsible for monitoring. They were the only ones having access to this information for real, and they were then steering from their central position all the different teams around them and telling them what was going on. So one of the first things Maxim and I was, okay, how good is the coverage of our monitoring actually? And we got this report that was mapped against our CMDB, and it showed that we had a coverage of 99.8% of our infrastructure components that were on our CMDB were monitored. And that sounds fantastic. 99.8% was a great number, and I was really happy to see that. So we had a great coverage. But actually the question wasn't about the coverage, but the question was rather how relevant was the monitoring. So I asked to get a picture of, basically put all this information into one picture, but that wasn't really possible. So one of the first things that we did then was that Maxim set up a small Grafana instance, and we visualized in this Grafana the state of our infrastructure, of our servers. And this picture looked like that. Now, I guess you can imagine the reaction once we saw this very colorful picture. And we started to understand what was going on. But to really get a good idea about it, I would suggest we just shortly now go to my living room, and I will give you a good explanation there on what was really going on here. Now, let me make this even more visual for us. So we would have these incidents, and we would just look at them, and they would become more and more and more, and we would still just be looking at them. Because there are so many of them, we wouldn't know which one to focus on. Until eventually, one of them becomes an incident. And now we know that something's on, and we're trying to solve it. We're trying to react. And only if we put enough effort into it, and we're maybe a bit lucky, we would solve the problem. But just imagine the fire would get out of hand. So I hope this makes it very clear on what the problem was. So one of the things that we right away went and put into place was a Grafana service that made the information available. And you see here one of the screens that we actually have within DevOps enablement. And this screen is sitting in our office. And whenever something is turning into yellow or even red, people react right away. And there's an unease feeling about it. I mean, nowadays, in this Corona times, of course, you are not sitting in the same office, but at least to have this available and that the entire team, not just an ops team or a small team somewhere, but everybody has access to the status is really, really powerful when it comes to resolving the problem. Okay, so we had solved quite a bit, but there is still a lot of question open on how we get forward. So we set up a vision of what we actually wanted to achieve within not just the monitoring services, but within DevOps enablement. We said our goal is that we will have empowered, autonomous digital teams that can take care of both the planning, the development, and the life cycling of their products, and get the tools out of one hand and get the tools from us. So in order to do that, we had to do some significant changes in our setup. First of all, we decided from the monitoring perspective that we are not going to one big solution that shall fit everything, but that we're going with the best of breed setup. So we will put the best tools in place, like Influx for metrics monitoring, and we'll make sure that the teams that are out there that are really capable of utilizing these tools have the best stuff at hand so that they can move fast. Now the second thing is, and here we are talking about being fast, is that we wanted to provide self-service. The goal is basically that the teams don't have to interact with us, but they simply have to interact with our tools like you do when you use a SaaS service. You don't want to be getting in touch with someone, placing a ticket or putting a request out there. You just want to get started. And that's as well our goal. And for that, we want to provide self-service. And the third point here is actually playing into the exact same thing. Accelerate the teams by removing the dependencies towards us. In the previous setup, we were basically being the proxy sitting in between the teams and the monitoring rules. In the new setup, take the proxy away and make sure that the teams can interact and work with the tool right away, because then they can be really fast. And the last one, I think a very important one, is don't rule. Don't demand a certain tool just because you believe it's the best one or just because the finance says it's the best one. Of course, you have to think from a smart financial perspective, but the best way is, and that's our approach, if our tools are that good that the teams are not even looking outside of the company for substitutes, but that they use our tools because we provide them an added value. They're better than the stuff out there. That's the approach that we're going for and that we're trying to provide. And by that, to convince the teams not even to look out there, but to stay basically with us and utilize our tools. Now, I assume that you're quite a bit interested now in how our setup looks like. This is the DevOps enablement stack or ecosystem as it looks right now. And it is constantly changing, of course. We are always looking into how can we become better, what tools are out of date, where do we have to do some replacements. But I'd say right now that's quite a fair state where we have. And you see basically coming from below, we have the different environments that we are providing. Of course, we are going more towards cloud and less towards on-prem. Then we have you can plan, you can develop, you can ensure your quality, and you can operate and monitor your environment. And as well, we have some logging capabilities just on top of them. And one important piece here, especially for the monitoring of our infrastructure, is then Influx. Besides that, you see as well, we have Grafana. We have a bit of NOI from IBM as an event handler. And then from the application sides, we are using the native stuff that's available within the Azure platform that we're using. And then a bit of synthetic transaction monitoring from Apika. And then on top, of course, we have logging, and there we are using the Elastic Stack. Down on the side, just as a comment, is ServiceNow. I just wanted to have it mentioned at least that we're using as well ServiceNow and have direct connections to ServiceNow, so we can, for example, set up an auto ticket that is created in ServiceNow, but that's not something that we are taking care of in our environment. I think I've talked now about transparency by providing the dashboard. I've talked about as well the self-service and make sure that you understand why self-service is so important to enable the different teams. And the last point I mentioned I wanted to talk about was the maturity level, or was the mindset actually behind working in a DevOps way and making sure that you understand the responsibility of the entirety of your product, that you're not just developing something, throwing it over the fence and someone else is taking care of it, but that you are aware of your responsibilities of planning, coding, quality, ensuring, and then monitoring and operating your product, because especially the two last parts of quality assurance and monitoring is not always obvious. And here we see as well that's a struggle. And you see basically the maturity in different levels. You have on the right side here around 20% of the teams in the organization, they want to go that way. They have already sometimes implemented tools in order to be faster. And they know exactly what they're out for. And I guess that from the audience watching this now, I would assume, thinking about last year's event, that around 80% or 90% are already as well in that corner. But then you have an enterprise, so you have 60% or you have quite a vast amount of people that are just need some time. You need to offer trainings, you need to offer advisory events, you need to make sure that they understand the implications of this change and they're going along, so they can become the race drivers. And then you have some, of course, where you are in the that will stick to the old setup and they want to demand the old setup, and there you have to work with maybe different tools in order to convince them, in order to move on to the train and go in the right direction with you, or you provide them some tools throughout the lifetime of their products and keep something small alive. That's about the mindset. But when everything works out, I just want to go back to my living room and show you how the new setup looks like and how it works when everything works out. Now, let me as well show you and visualize for you how the new setup looks like. So traditionally, we had all of these different alerts and the team that didn't know which ones to act upon because some of these alerts were not relevant. In the new setup, the teams are taking care of the alerts themselves. So most of them are already taken care of because they are configured the right way and are not showing up. Now, from the ones that still show up, most of them are being taken care of because the teams know how to handle them, what to do with them, why they occur. It might though still be that once in a while we have an incident.
Since we have the right processes in place and we know what to do with it, we have a much quicker resolution time. Thank you.
Oh boy, how serious I look in those videos. That wasn't meant to be. Anyhow, I hope you got a good understanding of the reason for this change that we've done here at Volvo Cars. I hope you got a good understanding of the 3 topics that I really wanted to highlight today. Now with that, I would like to hand over to Maksim and let him tell you a little bit about more the practical side of both the advantages that we created as well as the challenges that we had, and how it actually really looks like from a technical perspective, the setup of Influx here at Volvo. Thank you.
Thank you, Daniel. And now I'm going to talk a little bit about how we maintain and operate capacitors together with Influx at Volvo Cars. So I'm going to talk about why do we need this, what kind of challenges we have with with capacitors and an enterprise version. I will show you a little bit our infrastructure, how we run Influx, how we run capacitors, and I will show you the life cycle of private capacitors we deploy for our users at Volvo Cars. But first of all, why? And as Daniel mentioned, the transparency and self-service is a key. Our organization in the past was struggling with a lot of complex processes, change requests, and it was really hard to keep the speed of the changes of the movement. So we did change from the classical way of working towards agile. And as of now, for today, we have some teams, they are already changed a lot. Some teams may be a little bit slow in this transformation, but in general, we are on the way. And the future of this transformation is enabled teams with different tools, including monitoring tools, to make efforts together for the same or common targets. And we are at DevOps Enablement, we're trying and we're helping the teams in this journey, in this transformation. That's the reason why we have a lot of focus on self-services. Here, the tools or technologies we use at the DevOps Enablement team, and we use to provide our users, to enable our users with different tools: Grafana, Terraform, Influx, and many other tools, automation tools. As Daniel mentioned, we have much bigger set of technologies because we not only provide the monitoring services, but we enable users with different tools. But now I'm going to talk about how we manage and operate Influx. So on the left side, it's pretty standard setup, the telegraph agents, custom scripts, and transportation layer. The users can choose between 3-scale platform we use as an application management and integration platform, or Kafka service. Kafka service we use to deliver telemetry collected by telegraph agents or any other agents. It's not necessary to be telegraph agents. And all telemetry received and collected by the agents will be delivered through ingest telegraphs in the middle. And the telegraph agents, ingest telegraph agents, will replicate the measurements and metrics into 2 instances: the production Influx database and development Influx database. And the key point here is the same data is replicated, exactly the same data is replicated on both clusters, making possible to develop and configure and test scripts, tick scripts, using exact the same data, amount of data. They also have two databases on each instance. The short-term database, then we keep all raw data, and long-term database, then we keep clean data. And in order to clean up this data from, let's say, unnecessary data, we use whitelist capacitor instances. And the capacitors, alerting capacitors. We have both clusters, enterprise version, then we'll have at least two capacitor instances running in parallel and handling critical alerts. And then a bunch of private capacitors used by our users to develop scripts and to test scripts. And whenever they are ready to deploy the scripts into enterprise version, they will just change the meta information on the script. And the script replicator function will move and sync up these scripts up to enterprise cluster. And the thing why we have these private capacitors in the picture is because we have to provide self-services for our users. But while using enterprise version, we cannot get the access level granularity to make sure that different teams, they can work together. They can change their own scripts without affecting other teams. So we went to this solution. For each and every organization or business unit or team, it can be big team or smaller team, depending on the needs, they can have their own private capacitor connected to their own chronograph organization. And in that case, they will be kind of isolated each other, but they will use the transparency because they will have access to all the data in Influx database. So they can create alerts based on the data they do collect, or maybe some other teams collected. So here we meet transparency and self-services. And as I mentioned, we use white listening. And for white listening, we use private capacitors. And at this level, we have to manage somehow what kind of measurements is okay to move to the long-term database and what kind of measurements it's just something we can use short-term. And we don't want this data in the database for 2 or 3 months, for example. So we did implement repository and Azure release pipeline. So our users, they can make a pull request and mention or add additional measurements they want to see in the long-term database. Our team will receive approval request, and after review and approval, the tick scripts will be generated and updated on both production and dev environment. So we will see the new measurements came in long-term database quite quickly. So it's, again, all about self-services. The only thing is we just verify if the new measurement is in a good shape and well-formed. So now the private capacitors, how we manage this bunch of capacitors. We have many different teams, as I mentioned, small and big teams, and they might have one or many private capacitors for different reasons. Let's say the hosting services organization is quite big, and they have smaller departments like Linux or Windows, and they might have separate private capacitors for Linux and Windows division, for example. Or it can be one big private capacitor. Again, it depends how they maintain their own alerting scripts, the tick scripts. So to make it flexible and fast, we use AKS cluster, Kubernetes cluster on Azure, and we deploy all the private capacitors on these AKS clusters. Together with these capacitor instances, we also deploy and maintain other artifacts from application gateway and the rules DNS records for each and every private capacitor. They also deploy and maintain ingress controller and ingress controller rules and private capacitor services itself. They also store the data, database, capacitor database on the Azure storage account. And by storing this in an external Azure account, we can easily backup or move the database from one AKS cluster to another without downtime, or let's say without noticeable downtime by the end users, because we can spin up the new private capacitor instance on the second AKS cluster and switch to this one in milliseconds. So how do we maintain this and operate this?
Right now, I will deploy new private capacitor, and on the left side, I have metrics monitoring repository, where we have all infrastructure components defined as a code and used by Terraform to deploy all the artifacts we need to run capacitors. On the right side, I have a Grafana dashboard, and as we can see, there is 4 active capacitors for the moment. So I will go to the repository, to the layers folder, and in this folder we have 3 different directories: ingest capacitors and ingest telegraphs. We use to define our whitelisting and receiving telegraphs, and the private capacitors itself. In the main file, we keep all private capacitors we have currently active. So I will edit this file, and I will simply copy and paste one of these models and say, I will name it like InfluxDemo. This organization name will be used by Terraform to deploy all the artifacts we need to run a capacitor for our users. And I will keep all settings default, but if needed, I can override some parameters like to increase CPU or memory size. And now I will just commit my changes and update the comments. Like this. So now I commit this. And I'm ready to create a pull request. Everything is ready, so I will just click create. Now my request needs to be approved, so I will approve it and complete. From this moment, my change will be taken by automation by the release pipeline, and my changes will be implemented in our environment. I can jump to the master branch and see the status in progress, and I can track this progress real time. So I will switch to this view, release pipeline. Okay, now it's loaded, and we can see we're already on the 5th stage, Terraform validation. And we can see basically the logs, how it's progressing. So we can see different stages already completed and succeed. Now it's validation, and it will plan and apply the changes. I can show you this list. We use Terraform specific version for compatibility. Then we have initialization and validation of the code. Then the plan, and actually the changes will be performed by Terraform on the last stage. If everything is good, we will see the green stage, and it will update the Grafana dashboard. This the plan activity can take about 2 minutes because in this stage, the Terraform will verify and compare the state we described in the code and the real stage on the state in the environment. And if there is any difference, like in our case, we added new private capacitor instance or module. So Terraform will recognize like we have this difference, and then we'll plan the action to deploy this additional instance of capacitor. And of course, it will also create DNS records. It will create the rules in traffic and application gateway. We'll create the passwords and store the passwords in Key Vault. So we can take these passwords and configure chronograph organization to connect to specific private capacitor. And we can see the status is changed to succeed. And in about some seconds, maybe 10 seconds, the dashboard will be updated. Here you are. Now we can see we have 5 active capacitors running. So new capacitor deployed, and it's start sending the metrics into our Influx instance. So we can see the trend of the memory utilization, and we can see the health is green, meaning no errors reported by private capacitor. So that's it. It was very simple and quick action. The most time we spent waiting until Terraform plan action will be completed, and then the actual implementation by Terraform apply. But from our customers or internal customers, our users, it's very simple activity. They will just make the same changes like I did in configuration file or in the model file by adding additional private capacitor instance. And our team will review the change just to make sure if it looks good and everything all right. And then we will approve and push these changes into the live. In reality, in this demo, I'm using only one stage, but in production, we use 2 stages, dev and production. So if there is something wrong, the dev stage will fail, and we will simply revert the changes, and the production will not be affected at all. That's it.
So we also, together with these private capacitors, we also deploy the self-monitoring components, the file bits to collect cluster-wide and private capacitor logs. And we also deploy the telegraph sidecars and cluster-wide telegraphs to collect the telemetry from the capacitors. And all this information is available to our users through Grafana interface, or they can also use Influx database query or Elasticsearch and Kibana. So by doing this, we can ensure our users, they can also investigate and see what is going on under the hood. So then they develop new tick script, for example, they always can see how many errors, or if any errors generated, how many data points received and produced by a specific tick script. Or they also can see how the private capacitor behaves in average in this specific AKS cluster. So I also mentioned we have 2 AKS clusters. And by having 2 AKS clusters in parallel, we can simply move some private capacitors from one to another. And we use it, for example, when we need to upgrade the version of AKS cluster, or we need to perform the test of the new functions or new capacitor version. And we can pick some pilot users and change the active cluster for them by moving to another AKS. And after the testing, we can move the rest of these users to new cluster, for example, if we upgrade the AKS cluster version. And there is so many components, so many artifacts we need to take control of. And when you do this manually, there is a lot of space for mistakes. So we also introduced an infrastructure as a code for our private capacitors, and not only for private capacitors, but we also maintain the whitelist capacitors and ingest telegraphs, as I mentioned before, using infrastructure as a code. This is a beginning of the journey. In Fluix database, we still keep operating in a classical way. So the private capacitors and infrastructure as a code. So we use Azure repository to keep this code. And this code is also available for our users. So users can make a pull request and create new private capacitor instance by self after approval. They use also release pipeline to sync up these changes, to initiate and automate all these changes made in the code. And the Terraform will take care on updating all the components we need to update, from application gateway down to private capacitor instances and down to self-monitoring artifacts. So here is a life cycle of private capacitor. But again, what is going on then? We will need to deploy new private capacitor. And the journey is pretty simple. So here again, the picture of our environment or infrastructure and all these private capacitor components on this screen. And the first step, it will be to change repository by adding additional private capacitor record. So after we did these changes in the code, and we did create a pull request, the next step I was approved these changes, and these changes by Azure release pipeline will be replicated into the Terraform, and the Terraform will plan the changes, and the Terraform will apply all the changes in the real infrastructure. And as a result, the new private capacitor deployed together with sidecar telegraph agent, the new ingress controller rule also deployed in this AKS cluster, new DNS record created, new rule in application gateway also created, and they also keep the passwords generated in Azure key storage, in the key vault. So the next step we will perform is to configure chronograph organization and connect newly deployed private capacitor. So we will take the DNS record, and then we will take the password from key vault, and that's it. It's ready to go. So this is how we manage our private capacitors, how we provide end users with self-services, how they can deploy new private capacitors for themselves or request this, better to say, or how they can add additional measurements in the whitelist. There is still some manual tasks we need to perform, like we need to configure chronograph organization, but it's also on its way. And in the future, we will have automation from end to end. So thank you very much for listening. Thank you, Daniel. Thank you, Influx, for this opportunity to speak.